Welcome you all. Today we are learning the subject of your the circuit theory or the network analysis. Today we will go through the revision part of your the introductory of your the chapter, that is nothing but your the two-port network. So in the two-port network, already we have studied, learned about what is mean by the port, how that port will be affected, what is the use of your the two-port network in the network analysis. We know very well for the transmission line, or you can say for the simplifying or reducing the circuit, complex circuitry, we are interested to go for the next method, that is nothing but your the two-port networks. In that we have seen, we have studied the various types, parameters of your the two-port network. So first of all, it must be clear that the two-port network are nothing but your the terminals, and the terminals may be the one port, two ports, or the multi-ports. It depending upon that port, the terminal will be reflect. If you are having a one port, so at the time two terminal. If you are having a two port, the four terminal will be there. If you are having a multi ports, that time many more than the four terminal will be reflected. So in short, that port is required for transmitting and the receiving the voltage source, the voltage across that circuitry, as well as the current which is flowing through the circuit, that we can find, we can what we can say, the calculate at the time of calculation, that is required. Okay, so in short, the circuitry or the network which we are having, and we are finding the equations by getting that voltage and the current flow. So that equation will be that network will be in the linear form. That is too important. Okay, there should not be any kind of the variation or linearity. Network should be there, so that the at the input, this section will be at the input side, and this section will be at the output side. So whenever you are having the voltage as well as the current, that should be on the two side. One will be at the input side, second must be at the output side. The at the input side, whatever the terms are there, that will be in the form of your the ones, and whenever you are having the at the output side, that will be the notation will be the two. Just because of the our better understanding, we should aware how the current is flowing and how the current is getting back. See here, at the input side, the current is entering and leaving. Similarly, the current is entering and leaving. Only the notation is that here will be the output port and here will be the input. The terminals are segregated, and the voltage across these two also different. That is, the V1 I1 will be at one side and the V2 I2 will be at the other side. So why we are preferring this two-port network, this which is one of the method to simplify the numerical, to reduce the complex circuitry, to for the time consuming, or you can see the many more things are there. That is nothing but for useful for the communication, useful for the control system and the power system and the electronics. Okay, because already we are aware there are a lot of methods by which you can what you can say, simplify the mathematical modelings. Okay, so this is also one of the method by which we can simplify with the help of the various parameters. In this case, we are having the dependent and the independent variables also, and the dependent and the independent variables are nothing but your the current and the voltages at the input as well as the output sides. Okay, so if you learn about these parameters or the networks, so various kinds of two-port networks are available. With the help of any one of the method you can use, and you can simplify the entire circuitry. Okay, you can reduce the circuitry depending upon the method which you are going to use. So the if you are going to use the impedance parameters or the impedance method, so at that time that impedance is denoted by the Z, and it is also known as your the open circuited parameters. Just because we are going to keep your the, if I'm observing from the input side, definitely my output will be the open, and if I'm observing from the output side, the input will be the open. Likewise, it's indicating either the open circuit or the impedance or the Z parameter. Similarly, the Y parameters, in the Y, that is also known as the short circuited parameters, and the admittance parameters. So here, if I'm looking from the input side, output will be your shorted. If I'm looking from the output side, the input will be shorted. Likewise, the name itself indicating here, the hybrid third is nothing but the combination of the Z parameters as well as the Y parameter at the input as well as the output. So by combination of that, that is nothing but the hybrid, that we have seen, learned about that one also. The notation will be here. the Z11, Z12, Z21 and Z22 will be in the Z parameters, whereas in the Y11, 12, 21 and 22 will be there just because of the 4 terminals. Similarly for the H11, 12, 21 and the 22, H22. Likewise, inverse will be the G parameters. Opposite to that, vice versa case. If input is whatever, if I'm assuming the open and the output is a short, so that will be vice versa. The input will be short and the output will be the open. Likewise, that will be in the G parameters of the inverse hybrid. Similarly, the transmission parameters, that is the A, B, C, D denoted by that, and inverse of that, that is A dash, B dash, C dash, and D dash will nothing. That will be the inverse transmission parameters. So similarly, here in this case, how that things can be reflected, that we will see here the open circuited or the impedance Z parameters, how we can provide that in terms of the function or the equation, that is a V is equals to F of I. Okay, V is equals to F of I. That is a V is a what we can say the voltage and the function of the I. So in how we are writing that, see here the equation of the voltages at the input as well as the output side in the Z parameter. V is equals to Iz. Instead of R, here will be the impedance. Okay, V is equals to Iz. Similarly, again this V will be Iz. So 1 1 1 2 2 1 2 2. We remember this will be the fixed one. Z11, Z12, Z21, Z22. Similarly for the Y11 means 1 1 1 2 2 1 2 2 will be the fixed. Only that there will be the change of your the ports which you are going to use. If you are using the Z parameters, here will be the Z. If you are using Y, whether you are using H, whether you are using the G, A, B, C, D and the A dash, B dash, or in other way, if you are not able to write the, in many textbook they are referring the different notation for the inverse cases, maybe the dash cases or maybe the smaller, don't get confused. So here the place will be the fixed one, 1 1 1 2 2 1 2 2. Only the parameter will be changed. Here will be the impedance, here will be the admittance, here will be the hybrid, inverse hybrid, transmission line and the inverse transmission line. So see here, if I'm writing for this the voltage equation in the Z parameter, so the vice versa case will be the for the Y parameter. See here, I'm writing this equation for the V, here I'm writing for the I, because they are vice versa to each other, because Z is equals to 1 by Y or Y is equals to 1 by Z. Likewise, this matrix will be for the I1, this column for the I1, this column for the I2. So opposite, that is the I will become as a V, and again the I will become as a V, but only the notation will be the same, that is nothing but the 1 1. Similarly for the hybrid, similarly here will be the voltage gain and the current gain you will get in the hybrid, you will get in the inverse hybrid. Okay, and again in the transmission line we are using the notation of your the A, B, C, D. Likewise, and inverse of that is nothing but inverse transmission line. So in this way we will simplify the numerical on the basis of the what we can say all the parameters. Okay, so see here how they are reflecting on which particular point we can say this is my 1 1 1 2 2 1 and 2 2. See here, if already we have discussed, we are having in the two port 4 terminals, terminal 1 2 3 4. Likewise, the current which is going is will be the I1, the current which is going from the output side is I2, the voltage drop across the input side is the V1 and this one is the V2. So likewise for everyone, Y11, Y12, Y21, Y22, H11, H12, H21, H22. Likewise G11, G12, G21 and G22, and the A, B, C, D. Likewise, so in this way how we can write the expression, that is too important. Equation number 1 and 2 we are writing in the Z parameters. We are interested to write the equation in the form of your the voltages. Okay, just because of the independent and the depending upon the independent and dependent variables. So in this way you can write the expression equation number 1 and the 2, and you can not replacing, you can write for the better convenience, you can write that same equation in the form of your the matrix, same equation in the form of your the matrix. See here how I am writing. At the input side I am taking as a that is a voltage 1 and the voltage 2. Similarly at the output side there are the two things are there, one is nothing but the Z and other is nothing but the current. See, observe once again. See here, if you are going to observe V1 and the V2 at the one side, and the other side is nothing but your the Z and the I are nothing but the two I's are there, that is I1 and I2, whereas the Z's are in the four notation 1 1 1 2 2 1 and 2 2. So in short we can say two parameters are there. So how we can write that in terms of the matrix? So see here the input, see here the output, and along with your the Z parameters 1 1 1 2 2 1 2 2 I1 I2. matrix. Okay, so this z parameters are used to determine all the values of your the 1 1 1 2 2 1 and 2 2, and depending upon the two cases you can whenever you are going to evaluate the things, the two cases you need to apply. One will be at the input port, whether the input port is open circuited or whether the output port is open circuited. If the input port is open circuited, definitely the amount of a current which is flowing will be equals to 0, whereas if your output port is open circuited, definitely my output current will be treated as a 0. So this condition is too important while you are going to simplify the things. So see here, if you want to write in terms of the formula, so definitely how I can find my third thing. First step is nothing but write the equation. Second step is nothing but go for the matrix. Second will be the formula, and third will be the matrix. So in this way you can find the unknown parameters 1 1 1 2 2 1 2 2. Already I have explained, we have learned this z apostrophe s will be your the v as well as I. Z of Vi. So V will be the one and I will be the one. So see here the ratio, because Z is equals to V by I is nothing but the basic formula of your the impedance. Z is equals to V by I. So 1 1 will be the 1 1. When this will be the 1 1, when the I2 will be equals to 0. Similarly, the second case, whenever you are finding for the I2 these two, always remember simultaneously find these two cases. Okay, if you are if the what you can say when you are keeping substituting the I1 is equals to 0, find out these two cases, fine. So in this way it will be easy to you to find the unknown parameter by considering the conditions, whether the input port is short circuited or whether the output port is short circuited. Getting? So you can substitute the value 1 1, 2 1 is here, 1 2 is here, and 2 2 is here, and apply the condition of your I1 is equals to 0 and I2 is equals to 0. Likewise you can find for the rest of the parameters, that is nothing but your the Y, that is nothing but your the H, G, A, B, C, D. Likewise, see here how we can represent the notation one Y11, Y12, Y21, Y22. So the voltages will be at the input V1, and here will be the V2, I1 and the I2. Likewise, you can find that is admittance. Okay, and you can write the admittance in terms of the equation is nothing but in the form of your the independent and dependent variables. So here in this case, this is the vice versa case of your the impedance. If you're not going to remember directly, you can remember like it is opposite or the vice versa or different, like you are the impedance, that is a Z. So see here in this case though we are writing for the I, in the previous case it was a V. So similar the parameters will be y11, 12, 21, 22, and here will be the voltages at the input, voltages at the output. So V1 years, V2 years, and I1 and I2. So how I can replace this equations in terms of the matrix, how I can write that one. So see here, this is the input side, so I1 and I2. These are the two things are here reflecting two things. One is nothing but the Y. So in one bracket is a Y and second bracket will be the V. So Y in the Y brackets 1 1 1 2 2 1 2 2, and in the V that is nothing but the V1 and the V2 by observing this equation number 1 and 2. So similarly, how we can find that unknown parameters with the help of the formula. So two cases will be there. Input port is short circuited or output port is short circuited. Likewise, V1 will be equals to 0 or V2 will be equals to 0. Whenever the things are coming here, if you are taking the conditions, V2 is equals to 0, simultaneously find these two cases, that is Y11 and Y21. So here the ratio Y is equals to I by V. The basic formula of Y. The Y is equals to I by V. So I by V means Y apostrophe S will be I and the V. So here both will be the 1 1, and the voltage across that will be the 0. Okay, potential will be the 0. Similarly, 2 and the 1, again the V2 will be equals to 0. Y12 and Y22 whenever the input voltage across that one is 0. So in this way, see here 1 and 2, that is nothing but apostrophes of I and the V. I and the V. So in this way you can find the next is nothing but the hybrid, that is nothing but the combination of your the Y and the Z impedances. See here in the hybrid cases how we can find, that is I1, I2, okay, in the two-sided, and V1 and the V2 in the, so because just because of the combination it's very difficult to write the expression for the hybrid. But we know very well the by observing the Z and the Y. So this equation will be treated for the Z. This equation will be treated for the y. If I'm writing for the z, definitely I'm interested to write the equation in the form of the v. Wherever I'm thinking about the y, definitely that will be the item. So combination of that is nothing but the hybrid at the input and the output. Input rating as a z, output rating as a y. So observe the z and the y equations and rewrite here. So only what is the change here? Change will be the h11 1 2 2 1 and the 2 2. The other thing, rest of the thing will be the similar. So here in this way, v1 and the i2 will be in the one matrix, and in the h will be 1 1 1 2 2 1 2 2, and the here is nothing but the I and the v2. So I and the v2, see here. So in this way, ultimate, if you want to note on the further, that entire term will be over the h. This entire term is nothing but equal the h of I1 and the V2. So likewise, H11 is nothing but again the V and the I ratio in the one cases, and in the other cases that will be the voltage gain and the current gain. See here in these two cases, H12 and 21. H12 and 21. In the 21, that is a current gain, and in the 12, that is a voltage gain, and other will be your the depending upon the Z and the Y parameters. Z and the Y parameters. How we can write, or we can draw in the equivalent circuitry of your the hybrid, how that h11 12 21 22, see here the series circuitry at the hybrid, and see here the parallel circuitry. This will be treated or looking like your the z, this will be looking like your the y. Okay, input and the output, how the current is coming and how the voltage across. Okay, so this way you can draw for all the parameters the equivalent circuitry. Okay, so ABCD will be here, how that 1 1 1 2 2 1 2 2, they can write for the A, B, C and the D notation. So here also, so how we can write if we observe it. So here will be the current gain and the voltage gain we are getting at this at the output side, and the other side is nothing but again the combination of voltage and the current, that is nothing but V1 and the I1. Other is nothing but voltage gain and the current gain. So in this way you can find the expressions. Okay, just because of that minus, in the transmission lines we can observe either from the input to output or output to input, forwarding and backwarding signals. That time that cases will be the minus case. So in this way we can write the expression for matrix in terms of the matrix, that is A, B, C, D, and here the voltages and the current equation we can find by concentrating the cases, two cases, that is the open circuit and the short circuited at the input as well as the output. Okay, and we need to remember if the input port is open circuited, definitely the current will be zero, and the short circuited, that voltage will be treated as a zero. So how we can find the unknown parameters of your the A, B, C, D with the help of the formula. So here the A and the D are nothing but the gains, that is nothing but voltage gain as well as the current gain. So see here the voltage gain V1 and the V2, whereas the current gains are nothing but I1 and the I2. So likewise, these are the vice versa ratio of your the voltage and the current that you can find the other, that is the B and the C. But the A and the D are nothing but the voltage as well as the current gain. Okay, so in this way you can find the parameters. So in the next is already we have studied that is nothing but the condition for the symmetry as well as the reciprocity or the reciprocal. So two ports network is said to be asymmetrical if its port can be interchanged without changing the port voltage and the currents. Means meaning should not be changed, even though you are changing, even though you are changing the what we can say that few things or interchanging, but the meaning should not be changed. It means that without changing the voltage and the current values, we are exchanging the values. So then the meaning should not be changed. Means the answer which is coming from there, that should be the same one. So just like you are the in the Z parameters, if I am getting the value of your 1 1 and the 2 2 are the same, it means that that is nothing but the symmetrical value. Okay, that is nothing but the symmetrical. How it is possible? That is nothing but 1 1 means V1 I1 when the I2 is equals to 0, whereas 2 2 is nothing but V2 and the I2 when the I1 is equals to 0. If I am getting by applying these conditions, still I am getting the same, then the what we can say, it will satisfy the symmetric condition. Similarly, the other is nothing but your the reciprocity condition. For the reciprocity, that is nothing but your the what we can say, how we can apply that one. Okay, how we can apply that one, reciprocity, that is nothing but the opposite form. out of the four terminals, two are satisfying the symmetry and two are satisfying the reciprocity. Okay, so see here the changes at the source size, at the source side, if there is a voltage source and that is nothing but you are applying the sources, and at the output side there is a short circuit, and same you are doing interchanging the things, vice versa cases. The input is short and the output is the source is applied. At that time I1 dash will be equals to your the I2 dash, that is nothing but the Z12 will be equals to Z21, because you are changing the position, you are interchanging the what we can say the places. The V will be replaced by if a V is open circuit or the supplied, then that will be shorted, and other will be if shorted, then that will be replaced by the supply. So in this way you can, you will be able to find the rest of the thing in the Z parameter, in the Y, in the H hybrid, in the transmission, in all cases you can find easily which are the symmetry, which are the reciprocity. Okay, so we always remember 1 1 and the 2 2 will be in the opposite case. Okay, in the Y parameters. Fine. So in the Y parameter. So in this way we have simplified related to your the what basic concept or the basic introductory part of your the two port networks. Okay, so this was the revision about your the two port network introductory part. Now we will switch towards the next, that is nothing but your the numericals. So be ready to simplify the numericals. So keep ready your notebook and the calculator. Now simplify the numerical on the basis of your the two-port network. So start here. The test result for the two-port networks are: A part is given, I1 is equals to 0.1 angle of 0 degree ampere, whereas V1 is equals to 5.2 angle of 50 degree volt. Second, V2 is equals to 4.1 angle of minus 25 degree volt. Okay. With the port 2 open circuited. With the port 2 open circuited. See here, read carefully, okay? Read the question carefully here. What is mentioned? We are testing the two port networks. We are testing the input as well as the output ports. What is going on here? Okay. So what is given in the A part? I1 is given in the A part. V1 is given in the A part, V2 is given in the A part. Okay, and what is the condition applied? That the port 2 is open circuited. The port 2 is open circuit. Now go for the B part. I2 is given, that is a 0.1 angle of 0 degree ampere, whereas V1 is given 3.1 angle of minus 80 degree volt, and V2 is given 4.2 angle of 60 degree volt. With the port 1 is open circuited, and find the Z parameters. So see here, they clearly mention the condition for the input as well as the output side. Secondly, in the A as well as the B part, they give in the values in terms of the polars, that is nothing but with the magnitude along with your the angle that is mentioned. So how by reading, after reading this numerical, how we can find the parameter, that is too important. How we can start? Always start by once read the question first. Secondly, note down the terms which is given, and third is nothing but which things you need to find out. This is a procedure to simplify the numerical. First, read twice numerical. Second, the given parameters. Then the third, unknown parameters. Then start with the formula so that you will get a more marks. Okay. Now come towards the thing. A part, you just note down all these things. B part, all note down all these things. Now what we need to find out? Find the Z parameters. It means that whatever the terminals which is having in the Z parameter, that is the Z11, 12, 21 and the 22, that we need to find out. So Z11, 12, 21, 22. How we can find? We know very well the formula. Z apostrophe S will be your the V and the I. If I am interested in the 1 1, definitely V and the I will be the 1 1. If Z21, then definitely the V and the I will be 2 and the 1. If 2 2, then the both will be the 2 2. And the last is 1 2 means voltage and the current will be 1 and the 2. See here the cases. At the beginning, the I2 is equals to 0. Okay, that is the output port is 0. Because they clearly mentioned the port 2. is open circuited. Open means I2 will be the 0. In the B part, what they mentioned, the port 1 is open circuited. Open circuited means I1 will be the 0. So at the beginning, find out with respect to the I2 is 0. Second time, find out with respect to the I1 is 0. So in this way, when I2 is equals to the 0, you will be able to find the two parameters, 1 1 and the 2 1. Similarly, for the I1 equals to 0, at that time you will be able to find the 2 2 and the 1 2. So see here the ratio, what is given in the V1 is mentioned as a 5.2 angle of 50 degree volt. Okay, similarly the current, which is nothing but your the 0.1 angle of 0 degree. So both are in the polar. So 5.2 divided by 0.1, okay, angle of 50 minus of 0 degree, both are in polar. So it is very easy to simplify this such a type of numerical, just because both are in the same. There is no need of conversion, there is no need of what we can say, the for polar to rectangular and rectangular polar, there is no need of the changing the terms. Okay, so 5.2 divided by 0.1, so you will get the magnitude of 52 with the angle of theta 1 minus theta 2, that is nothing but the 50 degree ohm. Similarly, both are again the numerator as well as the denominators are in the polar. 4.1 angle of minus 25, 0.1 angle of 0 degree, which is mentioned in the numerical. So here will be your the 4.1 divided by 0.1 is the 41, and the angle will be your minus 25. Likewise, the 4.2 divided by 0.1, 42 angle will be the 60 degree, and the last is nothing but 3.1, 31 angle of minus 80 degree. Likewise, you have calculated all the parameter. The last part, always remember, in a such a numerical, when you are going to find the 1 1 2 1 2 2 1 2 whatever, so at that time at the end will be, hence the z parameters are satisfied, and you need to write in terms of the matrix. What is the matrix here? No need, don't think about the V and the I matrix while you are going to simplify in such a type. In such a type, you require the Z parameters in the matrix, that is a matrix of 1 1 1 2, positions of that 1 1 1 2 2 1 and 2 2. Now note down whatever you got the answers. Whatever you got the answer, substitute the value of at a 1 1 1 50 52 angle of 50 degree. Likewise, the 2 1 2 and 2 1 and 2 2. So in this way you can simplify such a numerical. So if for the input port and the output port are given conditions, if the value for the voltages and the current is given, so first step must be, you need to find out all the terminals with the help of the formula, and just place the answer which you have got, that is in the form of your the matrix. Go for the next. Find the Z parameters for the network shown below. So see here, the three sections are there. This is the first, this is the middle, and this one is the last. So this is the input, this is the output, and this one will be the middle. That's why at the beginning, find the Z parameter for the network shown below. The value is given, that is 1 ohm, 1 ohm, 2 ohm, 2 ohm. The current will be at the input, it will be V1 and I1, and the output will be your the V2 and the I2. So we have kept the same thing, means at the beginning we remember, always we must remember the input, at the end we always remember that is output, and middle cascaded signals may be the other, you can assign the other notation for the currents. So see here, this will be your the I1 the current, and this will be your the I2. This direction clockwise and anti-clockwise totally depend upon how that current is flowing from the positive to negative or the negative to the positive. So likewise you need to draw that the direction of that current. So middle you can assume any, that is either the clock or the anti-clockwise. Okay, so see here this case, and see here this case. Here is the voltage source at the input as well as the output, whereas in the middle only all are the resistors. Is how we can simplify this such a numerical, already we have simplified in the unit number 1. Okay, basics of networks, that is nothing but with the help of the mesh analysis. Okay, so we have done how we can find with the help of the mesh analysis, that is nothing but by applying the KVL. So here the three loops are there, so we are interested to find out the KVL to the mesh 1, the KVL to the mesh 2, the KVL to the mesh 3. Okay, KVL to the mesh 1, mesh 2, and third is nothing but the mesh 3 middle part. So by applying the KVL to the mesh 1, which is nothing but this part, okay, which is nothing but this part. So how many registers are there by looking this one? V is equals to IR. V is equals to IR. So 1 and the 2 is nothing but the 3. So 3 I1. So next is nothing but again same amount. Okay, same amount. This 2 is flowing in this middle also. So 2 into I3. Which current is flowing in the 2? again the I3 current is flowing. So that's why V is equals to IR case will be twice. One you are writing for the I1, another you are writing for the I3, just because this is the middle. This is in intermediate register for the loop 1 and the loop 3. Similarly, this 2 is the intermediate register for the 2 and the 3. So this will be the equation number 1. While you are applying the KVL to the mesh 2 is nothing but here. Mesh 2 is nothing but at last. Okay, so this last case. So here will be your the V is equals to IR. So V2 is equals to R is nothing but the 2 into I2 plus this 2 will be for the I3 also. This 2 will be for the I3. So this direction, this one and this one minus minus will become as a plus, because we know very well V minus IR is equals to 0. So minus and this minus both are in the opposite direction. So minus minus will become as a plus. See here the observe here the case, here is the minus, here is the plus, just because of the direction of the current. So in this way you will get the equation number 1 and 2. Now go for the mesh 3, that is nothing but the middle part. There is no voltage source, only all are the current source. If I am going to start from the at the node at this moment, so here will be the plus, here will be the this 2 will be in bracket of your the, either you may write for the I3 minus of what you can say the I1 case, uh, I3 if I am here I3 minus I2, if I am here I3 minus I1. So likewise, if you are going to simplify that equation, you will be able to find such a case minus what we can say minus 2 I1 plus 2 I2 plus 5 I3 is equals to 0 will be the equation, other equation. Okay, if you want to simplify more, if you want to find out the unknown, that is nothing but in the two cases, the two cases which is the unknown, that is nothing but the I3, because we can find I1 with the help of this loop, we can find the I2 with the help of this one. Always remember, this is the unknown, that is nothing but the I3. That's why the same equation we are converting in a one of the unknown parameter, that is nothing but my I3. That's why I3 is equals to, I3 will be equals to 2 by 5 I1 minus 2 by 5 I2. 2 by 5 I1 minus 2 by 5 I3. This will be the equation number 3. Now you can equate all the equation number 1, 2 and 3. Which method we have used? We have used the KVL. How we have applied that KVL to the mesh? Now come to it. Substitute. This is very important numerical is going on. Okay, keep remember the steps. The value will be, the value may be changed every time, but the steps will be the common. Substitute the equation number 3 in the equation number 1. So what is the in the 3 is the I3 equation. So I3 you just substitute in the first equation number 1. Why we are substituting? Just because if you observe this case, in this case we are having I3, in this case also we are having the I3. In the both the cases, we are both the equations we are having the I3. Just substitute the value of I3. Definitely you will get the I1 and an I2. No need to find out that I3. Okay. So the substitute the equation number I3 in the equation number I1. So V1 will be equals to, wherever you are having I3, just substitute it. You will get the final. V1 is equals to 11 divided by 5 I1 plus 4 by 5 I2. Similarly, substitute the equation number 3 in the equation number 2. You will get V2 is equals to 4 by 5 I1 plus 6 by 5 I2. So if you observe now, what you are observing, the equation number, you can substitute here the equation number 4 and the 5 for the V1 and the V2 final. This for the V1 is equals to 11 by 5 I1 and the 4 by 5 I2, and the V2 is equals to 4 by 5 I1 and the 6 by 5 I2. You can give here the equation number 4 and equation number 5. By comparing the equation number 4 and the equation number 5 with the Z parameter equation, V is equals to IZ equation, you will be able to find in the matrix 1 1 1 2 2 1 2 2 will be equals to, observing the 4 and the 5. So 11 by 5, 4 by 5, 4 by 5 and the 6 by 5. In this way you will get in the form of your the matrix. Go for the next numerical. Test the result for the two port networks are, the A part is nothing but the port 2 is short circuited and V1 is equals to 50 angle of 0 degree, I1 is a 2.1 angle of minus 30 degree, I2 is equals to minus 1.1 angle of minus 40 degree. The B part will be the port 1 is a short circuited and the V2 is given, I2 is given and I1 is given. Whenever the word short circuited will come, definitely one thing should come in your mind, that is nothing but we are interested in the why, that is nothing but the admittance. Okay, and if you talk about the admittance, definitely that will be the vice versa case of your the impedance. So y will be equals to I by v. Okay, and if one is there, though definitely the apostrophe s will be the I and the v, I and the v, I v likewise. So here 1 1, just because of the 1 1 2 1, just because of the 2 1 1 2, just because of this ratio and to 2. So here the first condition is port 2 is port 2 is short circuited, the voltage across 2 will be 0. Second case, the port 1 is short circuited, that's why these two value you need to apply for the A part, the other two is for the B part likewise. So what is the I1 is mentioned in the A part, that is nothing but 2.1 angle of minus 30 degree, and what is my V1, 50 angle 0 degree. So 2.1 divided by 50 will be 0.042, angle will be minus 30 minus 0, so that will be minus 30 mho is the unit of this admittance. Similarly for the second, that is nothing but the I2, which is given as I2 in the equation minus 1.1 angle of minus 20, whereas V1 is a 50 angle of 0 degrees. Now minus 1.1 divided by 50 will be minus 0.022, angle will be minus 20 degree more. Third is nothing but go for the B part. Okay, so minus 1.1 angle minus 20 50. So here again minus 0.022 angle will be this one, and likewise all in the moho, the unit will is moho in the admittance. Compare all these things and write, hence the y parameters are in the matrix form, that is y11, y12, y21 and y22 will be your like this 0.042 angle of so and so minus 0. So and so, and you can substitute in the matrix form at the particular terminal. You just note down the values answer, you will get the full mark. Go for the next. Determine the y parameters for the network shown below. See here in this case also just similar to the impedance. See here the section 1, section 2, section 3. Okay. So in this case, this is 1, 2 and the 3. We remember the Z parameter is applicable for the series circuitry. That's why we preferred the mesh analysis. That is nothing but the KVL we have applied. Whereas the admittance, that is a Y parameters, is applicable for the parallel circuitry, that is on the node basis. That is nothing but you need to apply the KCL, that is nothing Kirchhoff's current law, just because of the nodes. So see here this section is 1, this section is 2, the notation node, this at this moment at the beginning will be, we are treating as a node 1, this at the end we are treating as a node 2, and this middle is nothing but the node 3. So at the beginning, I is equals to V by R. Ohm's law. I is equals to V by R. What is my V at the beginning? V1 minus of V3. This is the node, means V3 is here, V2 is here. Okay. Just because of this V2, I have kept here the V2 same. And this part will be the V1, and middle, which is nothing, that is nothing but the 3 part. V1, V2 is over. Now come toward the third, that is V3. So here V1 minus V3 divided by R, that is nothing but the 1. I is equals to V by R. So V1 minus V3 divided by R. Likewise, so 1 is nothing, so V1 minus V3. Now go for the next, that is apply the KCL at node 3. At this particular moment, node 3, incomings, outgoings, we remember just like a junction, a traffic light, you can at the junction point, you will be able to find forward, reverse, front, back, the traffic. So similar to that only at particular node. So at a node 1, so how I can write my equation? I can write my equation of your I1 is an incoming current. Okay, I1 is income, I is equals to V by R. So what is my V? V is a V3. What is my R here? What is my R is here, that is 2 plus next V3 minus V2. See here V3 minus V2. First I have written for this one. Okay, first I have written for this one, that is nothing but I is equals to V by R, V3 by R is nothing but 2. Second I am writing for V3 minus V2 divided by R, that is nothing but the 2. Okay, so simplify these two cases, you will be able to find V3 minus V2 divided by 2. Go for the applying the KCL at node 2. Node 2 means this one. Node 2 means this one. So at this moment I2, because I2 is here, I is equals to V by R. So V2 is here, V2 by 4, V2 which is across this 4 ohm resistor. So I2 is equals to V by R is nothing but V2 by 4. Second, plus of, again the I is equals to V by R, again V2 minus V3. V2 minus V3, which resistor is in between? That is a 2. V2 minus V3 divided by R. So here this I will be for the first case, I will be for the second case. So in this way 3 by 4 will be 2 minus V3 by 2, and here will be V3 minus V2 by 2. This way these two equations, once you got these two equations, you can substitute the things. See here, substituting the equation 1 in the equation 2. 1 in the equation 2. We remember why we are taking, which is the one, that is nothing but the this one in the equation 2. So which is this equation number 1, equation number 2, equation number 3. So 1 is we are getting at the place of I1, that is V1 minus V3. So just substitute wherever we are having the I1, substitute the V1 minus V3. So you will be able to find the unknown parameter, that is a V3, that is a V1 by 2 and V2 by 4. So substitute the equation number 4. This is equation number 4. V3 is equation number 4. So substitute the equation number 4 in equation number 2. So you will be fine. Final v1 by 2 minus v2 by 4. Again substitute the equation number 4 in the equation number 3. So you will find minus v1 by 4 plus 5 v2 by 8. The finally compare the equation number 5 and the 6. Finally compare. This is the equation number 5. This is the equation number 6. We got in terms of the currents, that is nothing but the admittance value. So y11, 12, 2122. Just substitute the value of this, the cases. Okay, that cases are nothing but the 1 by 2. No need to write the voltages. Okay, 1 by 2, 1 by 4 will be here, minus 1 by 4 and the 5 by 8. So no need to write this V and V1 and V2. Go for the next one. Find the transmission parameter for the network shown below. So here the only two loops are there, the input and the output, V1 and I1, again the V2 and the I2, 1, 2 and the 5 ohm, the register values. The transmission is nothing but again the ABCD. So here you need to apply the two cases. So two conditions are there to simplify the method. Two methods are there. One is reflecting here. You need to remember the open and short circuited cases. And the second method is nothing but with the help of the KVL and the KCL, you can simplify the numerical. Always remember there are two methods to simplify such a kind of parameters. One is known as by applying the condition of the open circuit and the short circuited, or the input and the output ports. Next is nothing but with the help of the KCL or the KVL, you can simplify the numericals. So in the previous slides, we have done the numerical on the open circuit and the short circuited, as well as we have done on the basis of KVL as well as the KCL. Now go for this one. For the ABCD, that is a transmission parameter. When the output port is open circuited, definitely I2 will be 0. So how I can write V is equals to IR. So see here, V is equals to IR. If I'm going to apply here, that is nothing but that the first case. So when the port is open circuited, so I2 is 0, this part is 0, so I am focusing on this part. V is equals to IR, V1 is equals to 5 plus 1 is nothing but the 6I1. Okay, if I'm going to write for this one, the 2 plus 5 is nothing, because if I'm writing directly for this side, if I'm observing from this side, so this V2 will be across the 5. So V is equals to IR means 5 across the I1. V2 is equals to I1. So now substituting the A, B, C, D, A and the C for the first case. So A will be the ratio of voltage gain V1 by V2, 6I1 divided by 5I1. So I1 cancel out, you will get 6 by 5. C, you can get I1 divided by V2. So when the I2 will be equals to 0. So what is my I1? So that I can write here. So 1 by 5, you can get directly 1 by 5. Okay, 1 by I1 is nothing but the current which is flowing in the 1 ohm is nothing but the 1, and the V2 is across that one is nothing but the 5. Go for the next, again the short circuited, when the V2 is short circuited. Okay, so at that time how I can find this one? How I can find, if my V2 is shorted as shown in the figure, if my V2 is shorted, so short circuiting, so how I can observe? The observation will be at the input side, this side. So R equivalent is equals to, so 1 plus, at this moment here will be the 1 plus, at this moment there will be the division of a current. So 2 and the 5, they are in parallel. So 2 into 5 divided by 2 plus 5, 2 into 5 divided by 2 plus 5. So and this term will be in series with your the 1. So that's why 5 into 2 divided by 5 plus 2 plus of 1. So you will get a 17.7 ohm. So likewise, how I can find my V1? V is equals to IR. I is I1 and R is nothing but the 17.7. So how I can find my I2? I2 is equals to, that is a which is going from this side. So I will be equals to, opposite to that direction is nothing but the I1. So I is equals to V by R. So uh, here in this case you can't take the V by R, you need to take directly how my current, short circuiting current will be opposite to the input current of that. Okay, so in this way you can, the second method is not second method, the other parameter, that is a BD. So this is the ratio of I1 and I2, this is the ratio of voltage and the current. Substitute the value, you will get the answer, and finally you can write that expression in the matrix A B C D. Substitute the value of 6 by 5, the 17.5 or whatever 1 by 5 and the 7 by 5 you will get with the help of simplifying with the help of this formulas. Go for the next. Obtain the ABCD parameter for the network shown below. Here the three loops are there, loop 1, loop 2, loop 3. So this will be 1 as it is, this will be 2 as it is, just because of the every time we are considering, and middle will be the third case. So by applying the KVL to the mesh 1, so I am applying here for the mesh 1. So V1, V is equals to IR. So V1 in V is equals to I will be R is the 1, so that's why directly 1, plus this 2 will be intermediate to the first and the third, so I1 minus of I3. So in this way I will get a 3I1 minus 2I3. Applying the mesh, what we can say the KVL to the mesh 2, that is nothing but the last part. At this moment if you are going to apply, so Vt is equals to 2 into 2 is the middle, that is what we can say I2 minus I3, I2 minus I3, but the direction of current will be opposite, that's why minus minus will become as a plus. So already we have simplified such a numerical how we can mention the direction loop. So current I1, current I2, and the middle will be I3. See here the notation I1, I2, and the I3. See here the simplification. Then again by applying the KVL to the mesh 3, middle part mesh 3, 2 to 1, there is no voltage sources. So directly if you're concentrating this 2, 2 will be I3 minus I1. If you're considering this 2, here will be I3 minus I2. I3 minus I1, I3 minus I2, and likewise the entire current will be flowing. You will get the I3 equation. I3 is equals to, because why we are finding I3, just because of the I3 is unknown. Once you got the I3, you can substitute that I3 value in the equation number 1 as well as the equation number 2. So see here, substitute the I3 in the equation number 1. Wherever you are having the I3, substitute that I3 in terms of this equation, 2 by 5 I1 minus 2 by 5 I2. So you will get V1 is equals to 11 by 5 I1 plus 4 by 5 I2. This will be the equation number 4. Now substitute again the I3 value in the equation number 2. So whenever you are finding the I3, substitute this value, you will get the I1 equation. So here the 4 and the 5 equation. Once you got the fourth and the fifth equation, substitute the what we can say the fifth and the what we can say the fifth equation in terms of the fourth equation. Okay, so you will find, then finally you just compare the matrix of yours, the A, B, C, D. So you will be able to find why we are doing all these things. We want in the standard form as per the parameter value. As per the parameter value, once we got, you can substitute a value of A, a value of B, a value of C, and the G. Next is nothing but in the two-port networks. So compute H parameter from the following with the output port short circuited. V1 is 25, I1 is 1 ampere, I2 is 2 ampere. In the second case, when the open circuited, so V1 is 10, V2 is 50, and I2 is 2 ampere. Input port, output port, V1, I1, V2, I2. So we are interested here the hybrid H11. So V1, I1, H21, that is the I2 and the I1, and H12 is nothing but again the voltage gain is here, current gain is here, and the 2 is nothing but both are 2 so voltage are 0 and currents are 0. So you substitute the value of V1 I1 here, I2 I1 here, V1 V2 here, I2 V1 V2 here. So you will be able to find 25 by 1 is 25, 2 by 1 is 2, and 10 by 50, and the 2 by 50 likewise. And finally you can write all the values which you have got. You can substitute in the matrix, that is a H parameter, H11, H12, H21, H22, 25.2 and 2 and 0.04 in the two-port network. So in such a way, if you are having directly the formulas, you can do. If you are not having in the loop form, then apply with the help of the KVL as well as the KCL, or other method is nothing but open or short circuit case. Determine the hybrid parameter for the network shown below. I1, I2 last case, middle is the I3, again the 1, 2, 2, 4. Okay, so likewise, so again this is the first method. When the port 2 is shorted, what will be the effects? Here the current will start flow, I1 will be start from here, the R equivalent, how you can find at this moment, this 2 and the 2 and the 4 are come in series with your, the 2 is with the parallel. So here will be at this moment, if node is here, so 2 and the 2 are in parallel, so 2 into 2 divided by 2 plus 2, and this 1 will be in series, so you will get the 2 ohm. So V is equals to IR, in this case V is equals to IR. So I is the I1 which is flowing, and R is nothing but the 2 ohm. So how we can find the H11, that is nothing but V1 I1, V1 is equals to 0, so you will get the 2 ohm. Similarly, other method If you don't want to simplify with the help of that, there is other method, that is nothing but by applying the KVL and the KVL to the mesh 1, mesh 2 and the mesh 3. So you will be able to find for the mesh 1 how the current is flowing. V is equals to IR case. The V1 is equals to 3 into I1. The second is the V is equals to again the 2 into I3. Similarly, V2 is equals to 4 into I2. Minus minus will become as a plus 4 into I3. Now go for the mesh 3. There is no current, there is no voltage sources. So all are the resistors. You can simplify and you can find the unknown, that is I3. You can substitute this I3 in the equation 1 and I3 in the equation number 2, just because the value of I3 is unknown in the both the equation of your the 1 and 2. Substitute the value of I3 in the both the cases. So you will find the rest of the equation, that is in the form of the I2 and in the form of I1. Once you got this equation in the standard form, why we are getting this I2 and the V1, just because of getting in the standard form. Once you got, just substitute in the matrix 1 1 1 2 2 1 2 2, like this. So in this way, we have tried today to the revision on the introductory part of your the two-port network, along with your the numericals 6 to 7 numerical we have simplified on the two-port network. So with all the parameters of your the Z parameters, the Y parameters, the hybrid parameters, the transmission parameter, 4 parameters we have done today in the numerical on the basis of your the two-port network. Thank you so much.